Okay, these notes are on the 6162 notes, perpendicular and angle bisectors. And our objective is to be able to use the properties of perpendicular and angle bisectors. So the main thing is, if a point's on the perpendicular bisector of a segment, then it's equidistant from the endpoints. Then it's equidistant from the endpoints of a segment, equidistant. So a picture might be, let's say we got a segment, let's call it segment AB. The middle, call point C. So we have a perpendicular bisector. Bisector, by definition, is going to divide the segment into two congruent parts. Any point that's on this bisector is going to be the same distance away from the endpoints of the segment. So in a way, this kind of sets up isosceles triangle. Those are going to be congruent base angles, and those are always going to be equal. So here we want to find out what the length of QR is. So let's look. QR is 5n minus 7. QP is 3n minus 1. Because this SQ is the angle bisector of segment PR, this distance from Q to R is going to be equal to the distance from Q to P. So PQ is equal to QR, and we have 3n minus 1 is equal to 5n minus 7. So add 1 to both sides and take away 5. We get minus 2n's is equal to negative 6. Divide by negative 2, n is going to be equal to 3. And it wants to find the length of QR. QR then is going to be 5 times 3 take away 7, which is 15 take away 7, which is 8. Let's look at this more practice. We want to find the value of x. Again, WY is a perpendicular bisector of TZ. So W to Z is going to be the same distance as W to T, since a point that's on the perpendicular bisector is equidistant from the two sides. So that lets us say that 2x is equal to 3x minus 5. Take away 3x's from both sides. Minus x is minus 5. Multiply by negative 1, x is equal to 5. Find the value of TW. T to W, since x is 5, TW is going to be 2 times 5, which is 10. Find the value of WZ. WZ is 3 times x minus 5, but x is 5, so we have 3 times 5 take away 5, 15 take away 5, comes out to be 10. And we see that WZ and TW are the same. What kind of a triangle is TWZ? It's an isosceles triangle because it has those two congruent sides. Okay, now the converse of the perpendicular bisector theorem, if a point is equidistant from the endpoints, then it is on the perpendicular bisector. And a lot of times I'll abbreviate like perpendicular bisect, like that. Should be a T. Okay, so let's see what we got. So if a point is equidistant from the endpoint, so say if point P is the same distance from R as it is from T, then point P must be on the perpendicular bisector. Angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Measured along the same angle. We'll see how that matters. The shortest distance is usually along the perpendicular. So let's see, example, if point S is on the angle bisector of angle PQR, then SP is congruent to, or the distance from S to P is equal to the distance from S to R. And we can say that SP segment is congruent to SR segment. Same thing would hold other than a perpendicular. Now this gives us the shortest distance. This PS distance is the shortest distance from S to the side of the angle, but we could measure distance along another angle also. As long as we're measuring along the same angle, we can see that we're going to have congruent segments. Now the converse of the angle bisector theorem is if a point is equidistant from the sides of an angle, then it lies on the angle bisector. So if point equidistant from sides of an angle, then it is on the angle bisector. So let's look at these examples here. So is point F on the angle bisector? If F is on the angle bisector, so we can see that FB is equal to FD since it's on the angle bisector, and that lets us know that 6x plus 3 must be equal to 4x plus 9. Take away 3 from both sides, take away 4x from both sides, we get 2x's is equal to 6, which gives us x is equal to 3. So we could figure out that this distance is going to be 21, and this distance here is also going to be 21 for BF and FD. Let's look here. How far is M from KL? Now, let's see if this is an angle bisector. So we've got like a hypotenuse leg congruence. So that means that this angle and this angle are congruent to each other. And this KL or KM divides this bigger angle into two equal angles. So KM is an angle bisector of angle JKL. And how far is M from KL? Basically, let's see what we could do. We've got an 8. Measured along the shortest distance, we can say that M is 8 units from L, and it is also 8 units from J. So it's 8 units from KL, it's also 8 units from JL, measured along the perpendicular. How is segment KM related to angle JKL? KM is the angle bisector. So I can say KM bisects angle JKL. Find the value of x. These two angles are congruent because the angles bisected, and also because these two triangles are congruent by hypotenuse leg, and these are corresponding parts. So we can say 3x's is equal to 54, divide by 3, x is equal to 18. Find the measure of MKL. M to K to L, we have a 90 and we have a 54. That adds up to 144. If we subtract that from 180, we get 36. So MKL must be 36 degrees. Find the measure of JMK and the other, MKL. Okay, I did that wrong. MKL is actually 54 degrees because they told us it's 54 degrees. And then using triangle sums, 90 and 54 is 144. That leaves both of these angles up here to be the 36. So that's actually the measure of JMK and LMK. They're both 36. Find the indicated variables and measures. Let's see what we got. So we can see that these two are going to be congruent to each other. So 5x plus 3 equals 7x minus 1. Take away 4 from both, or take away 3 from both sides, and take away 7x from both sides. Minus 2x's is equal to negative 4 divided by negative 2. X is equal to 2. And so we found x is equal to 2. To find EH, 5 times 2 plus 3 is 13. And to find EF, 7 times 2 is 14. 14 take away 1 gives us 13. And over here, we want to find AB. AB is 15 because of it being congruent. These two angles are congruent to each other. So to find x, we could set 2x equal to 3x minus 29. Take away 3x from both sides. Minus x is minus 29. X is 29. So we got x is 29. AB is 15. The measure of ACD can be found by setting these two equal to each other. Since these two angles are congruent, we have 2x equals 3x minus 29. So we get x is equal to 29. Twice 29 is 58. So ACD is 58. ACB is also going to be 58. And DAC is going to, I'll have to use triangle sums. We have 90 and 58, which is 148. Subtract that from 180, we get 32. So these two angles at the vertex are 32. DAC is 32, and BAC is also 32.